Hello everyone. So this is your math buddy and your math teacher Swapnil. I'll be covering a bit about probability here, and I'm focusing on grade 12 right now and McGrawhill Book, Unit 10.5. So I'm assuming right now that my students already know that probability of any event or x is always less than or equals to 1 or more than or equals to 0. It will stay between these two limits. And probability of any event, which is x or e, is always favorable cases divided by total cases. So when I say cases, I mean the outcomes, the possible combinations and permutations and all. Now, sometimes we'll be covering up a couple of other things, but maybe after a bit. So let's have a look at the first question. So always the first step is to underline the important information. 5 yellow, 6 blue, and 4 white marbles are in a bag. So I can write yellow. I don't need to write it actually. I'll just go on with the question. If you read the first part, it says, what is the probability that a marble, that means I'm choosing one, at random selected and it is yellow. So you can simply write probability of a yellow marble is number of yellow marbles divided by total. In this case, the total is, the yellow marbles are, let's say 5, and the total is 5 yellow plus 6 blue plus 4 white marbles. So that total will be 5 divided by 15. That's 1 by 3, which is your probability. The second part of the question talks about what is the probability that a marble, so again we are choosing one marble, will not be white. So when it says not, that means I want everything except white. So probability of not white, you can just simply write like this. Okay. But for now, first I will find the probability of white, which is white marbles 4 divided by total marbles 15. Now, as I said before, the probability of all the events is always 1. So if I want to find not white marbles, I can just subtract the probability of white from 1. So that means white 1 minus white, which is, so when you solve it on calculator or manually, you will get 11 by 15, which is your answer. If needed, you can convert it to the percentage, but generally probability doesn't ask for percent. So that's the left-hand side part of the questions. Now let's have a look at these questions. 20 computer chips are there and 4 are defective. So total number of chips, 20. Defective, so DEF, defective, 4. If I select 3 chips, so I'm choosing 3 chips. If 4 are defective, so I can find how many are good, like not defective. That will be total minus defective, and which is 16. Now, what is the probability that if I choose 3 marbles, like 3 chips, all 3 are defective? So I can maybe write it down like this: defective, defective, defective. That's what I need. I'll just write a P, probability of 3 defectives. Now, as per the counting method, we have to make the empty spaces first as per the need. So need here is 3 chips and all defective. So let's make 3 empty spaces, like 1, 2, 3. There is a multiply in between because it's like an and situation, defective and defective and defective. They are necessary. I need them. How many defectives are there to choose from? 4. If I have taken 1, how many left? 3. 1 more gone. So I am left with 2. Divided by total. So what is the total? 20. What is, if 1 is gone, what is remaining? 19. If 1 more is gone, 18. So you will always follow the similar pattern. Now, if you will solve that, manually or by calculator. So I'll just show you. Actually, this is kind of interesting. If you want to do it on calculator, it's a good idea to choose this. Write 4 times 3 times 2, and under it you write 20 times 19 times 18, 1 over 285. So that is the probability that all 3 of them are defective. Only one chance out of 285 possible cases. Now, the second part of the question, let me just move it a bit up. All right, so now they are saying find the odds. So I'll use the blue color to differentiate. They want me to find the odds that one chosen chip is defective. So if you remember, the formula for odds is that whatever the question need, you divide it by total cases minus need. So when I say need, I mean whatever the question is asking for, 3 defective, 1 defective, 1%, 10%, like that. In this case, my need is 1 defective chip, and total is total. And yeah, so I can just write it down like a simple statement, like D divided by total minus D. Now, how many are defective chips? In the question, if you will see, there are 4 chips which are defective. So 4 divided by, this is 4, you see, D. Total is already given in the question, 20. When you solve it, you will get 4 by 16. So the answer will be 1 by 4. Or you can also write it as 1:4. Please understand, this means that if there is 1 defective chip, then there are 4 not defective chips. For every single defective chip, there are 4 non-defective chips. So that's all about it. I'll be covering more in the upcoming videos. Thank you so much for watching. Have a nice day, guys.